Hey, so I'm finally going to sit down and demo Medusa. This is the first time that it's really been shown on video outside of a couple calls. There's still a couple rough edges around it, but for this demonstration, it should be stable enough to use. So, a lot of questions come up around what Medusa actually is, and uh, pretty much what we're going to end up seeing with federated apps is the need to have something like a runtime lock file. Let's say I have a group of applications like this, and I have them deployed out somewhere like separate environments. What I'm probably going to have is some sort of drift or some sort of compatibility drift between these separate components as teams upgrade or have various APIs, or if you need to go into a code freeze, some way, shape, or form, you're probably going to want some kind of version management for federated modules. Now, you can get this if you go with the shared mechanism, which is useful, but you then have the kind of double deploy of NPM, and you don't get the kind of runtime capability that Exposes has. Um, so they're a little bit different, and what we're trying to do is see how can we version what we're exposing. So when we change, something in the platform, uh, how do I increment this version, or how would I report the version back to some central system? And what kind of problems come up when you actually try to handle a real world scenario like that? So, the first thing we're going to want to do is fire up Medusa. So, what Medusa is right now is basically a Next.js application and a big GraphQL layer. Pages, API, there we go. So, you'll end up hitting this layer or this layer primarily. What we end up having on this end is this dashboard plugin, which we need to rename. And one of the things that it will accept is a token. So you can generate a token for it if you run this over the public internet or something like that. And it kind of sits as a container somewhere. It receives a bunch of data, and the idea is that you don't really hit this API a lot, but you mostly write to it and then use its webhooks and have it write somewhere that's more scalable. So we configure the plugin with this, some basic metadata, some of this still pending. And if I go into, say, like the homepage, look at my Webpack config, what I actually have on this host is I've got, a typical resolution for inline loaded scripts where they're just on the window, but I have the pattern library being managed over this client version command. And I pass in the current host saying, hey, I'm the homepage, the DSL, and the URL back to our GraphQL layer. When it hits this, what basically happens is we have a fetch request go off, which is pretty cool. And we go over and figure out a whole bunch of stuff. And we continue figuring out a bunch of stuff. Overall, not too complicated. However, this is not bulletproof. There are problems with it. Um, but for a first run, and if this was server-side data or something like that, this would be a whole lot easier to manage. So let's get this going. We've got it up and running here, localhost 3000. So we'll get Brave up. And when I run a build for my application, let's say dashboard example, I'm going to run a build command, which basically is just going to build everything, simulating a deployment. So what I end up with is a bunch of information being reported back to Medusa. Let's see. So if we look at my command line over here, we're going to see some data start coming back, which is basically just a log saying that, so-and-so's been updated or whatever the case is. And even with ES Build Loader, it's still slow. ES Build Loader sped up this use case, which is really cool, by about 50%. Right now, I am running everything with Webpack cache disabled. So each build is building at its slowest possible time. So seeing what ES Build Loader does on top of this is actually quite impressive. It's usually like 150-second build time. And there come 5 builds. All with varying things and outputting. This is actually the container that gets output, so it refers to it as an external, and then it's a new promise, and then it's a fetch to our GraphQL API, and we pretty much run it through a whole bunch of other logic. And that's built right into the host. That's how the host connects itself to a remote in the first place. Let's see, everything's up and running on the front end. And the build update that you'll get is something, to this degree. Application version, updating nav, updating home, so on and so forth. And it builds out an interconnected web. So it shows how everything is connected, what's its base URL, how does this thing show up, what's its typical remote in a default state, what are the consumers, where are they, what are they consuming, and you can click through and see the relationship of any part of the large graph. If we think of this system as a polylith, then this is what connects everything together. You can also look at a dependency table and kind of see what's being vended up and down. We can see React NatD is required. We can see button is shared by DSL and it's used by nav, search, and home. It's used 4 times on the home page. And, we've got a text field used twice in search, and so on. And we can see anything that we're overriding or sharing. One interesting view as well, it's still a little buggy, but is the node view. When you want to look at what the node view of this application is, how things get consumed and where they get consumed, it's quite handy. And this one's really nice, which is a chord graph. It definitely won't work at scale, so we'll have to look at breaking this down in like team categorizations or something like that with another query. But it essentially shows you everything of like what search is composed of, which pieces of search are used, where they get used. You can see all the interconnections between these 6 federated apps. So I can go over here to the home section, and I can look through it. I can see what I'm sharing. I can see direct dependencies that are being loaded, dev dependencies of it as well, and I can see everything that I consume and where I'm consuming it. And I also, if I have version management enabled, which is a custom built feature, but if we have version management enabled, I'm able to dictate what version is used here and be able to alter it. So if I go look at this example, I'm hitting port 3001. I have several other remotes up. You can see I'm connecting to several different remote containers. And you'll notice I have the pattern library on here. If we go and look at the DSL, look at its source, we can look at button. You can see button's blue. Let's try changing it to green. And let's go down to the package.json and let's version that 6. And I'll hop back over here and just simulate a deployment. And it's going to rebuild the CDN layer, which is my dist directory, which is holding on to these sequential builds. The idea is with the dashboard, we have the entire graph, or we can add on to the graph and we can record everything. So if you deploy this up to CDN, you can figure out when certain chunks are no longer being used and actually have Medusa manage your caching layer, what gets cached and what gets disposed of. So it could help actually bring down storage costs as things get shaken out. Other interesting ideas that I've had with this tech is like deploying something into the lower environments and having like dev tools that overlay your application, or notifications that could come in from, say, platform teams or something like that would be a really neat feature to have. And with something like Medusa, you can basically orchestrate, well, what gets loaded and where. So I could basically say, don't load this in production environments. When it sees it's in a production environment, some server-side rendered object will print out the commands for it, and the Webpack runtimes will read them and load the correct versions of themselves. Which here it could be loading remote entry 4, remote entry 5, and when the build gets done, we'll see version 6 come up. Then, if you still use an evergreen deploy, if you're not worried about versioning, then we always deploy out window.dsl, which is the latest version. So what ends up happening is the dashboard plugin or Medusa plugin creates this versioned remote here. It creates this incremented remote, and it's got all the logic in it to know how to find it and use it. So now I've got a build that's coming up. I should see version 6 appear in here and in my graph layer. Let's see. There we go, version 6. And it'll be green. So now I can go back to the home page and... Alright, so let's set it to version 5. Let's see. Alright. So this goes red. Now let's say I wanted to change the deployed version of the navigation. Because nav, if we go and look over here at nav, it will, let's see, what does it consume? It consumes things from the DSL as well. So if we go and look in its footer or header, we'll see, it needs button. So if I wanted to change the version of this button in the header, I can do so through here. We can go over to nav, and I could say, lock it at 5. I think it's at 5. Let's see. I think that makes it red. Yeah, there we go. And now this live application is now switching between 2 different versions of this thing. I still have the green version here, and I could go, okay, well, let's make the nav, something else entirely. And now we have 3 separate versions of the same navigation layer loaded on this page. And that's very powerful, because as you think about module federation, it's really great to join pages together, really easy to join pages together. But what happens when you break this thing down and you start to develop features and start looking at feature sharing? You, at some point, want some way to manage that. And if we look at microservices, RESTful APIs, they all have versioned APIs and things such as that. So, and those things are technically at runtime as well. There's, different routes that are available, but you could create the same kind of abstraction around federated module and how it communicates. One example of that abstraction here is, we're calling GraphQL. If I look at all my requests here, and Graph is telling us how to build our application. So when this application starts itself, it doesn't know what to do. The idea is we would server-side render this in the page somewhere, or the important parts of this response into the page, and it would dictate what versions would get loaded. So, it now shows me the version here, the name of it, so on and so forth. And why this is really unique and really cool is there's a very challenging problem with module federation, and that is that it works really great until you have a namespace collision. Where you most likely get a namespace collision? The most likely point is going to be when you have multiple versions of the same remote on the same page. And that's not really something you would think of off the top of your head, but if you look at a design system like this, which is federated, I can see it showing up in multiple ways, shapes, and forms, where I'll need nested lock file type capabilities, where each thing is controlled regardless of what its parent container is using. It is stable. And let's see here. So let's look at what DSL looks like. So everything goes to the window object, because that's what I'm attaching it to. And what I end up with is DSL, but I also end up with this DSL as well, which has the get and init API. And if I just go to window DSL, I have the latest version that's running, which I think is the green version, and I have the get and init API. So what's happening is we're basically under the hood with this client version technique. We're able to go to any type of build that we want, and we can set the target to be a promise or an external if we wanted to. I'm just trying to find the right location. There we go. So inside of here, I could say, okay, well, a very unconventional way of writing this, if I wanted to mimic the technology I'm using, would be something like this. I think it's promise, new promise. Let me check. Yes, all right. Copy that line of code. reason I abstract all this stuff. Okay, so we could have a promise here, and this promise could do something as simple as this. And it would give me the same effect, just asynchronously. Because that is where this object is stored. That's where the get and init API is. And all this promise cares about is that it resolves with the get and init API belonging to this key. So if we go back to the DOM and go to our console here, if I were to go Windows search, there we go. There's the object, get and init. So it doesn't matter, like I don't need it to be DSL. Like there's no reason that I can't create this on the server and, rename it and do all of that with a plugin and some runtime configuration. And, you can get the same kind of effect here. The big challenge comes in is how do you get these scripts to sequence themselves together? How do I make sure that these are all loaded in the correct order in the appropriate manner? And what happens when you have multiple scripts on here and you have multiple overrides on here and you start to play around with changing a whole bunch of things? None of these are connected at the moment, but this is where the technology gets interesting. But you could also use the same kind of, Medusa mechanism. I could go back to the homepage and I could put A/B tests on it somewhere. Another really interesting feature is I could, if I was deploying this out and versioning it, this would have a version history, and in theory, if you wrote the correct front end loader for it, or if I wrote the correct front end loader for it, what would end up happening is I could roll back at runtime the home page itself to a previous version. So just like how I can roll back DSL, I could also actually do it to the host itself and have the host load a previous copy of itself in the event of some kind of critical error. So hooking this up to Sentry or something like that, you could have self-healing technology. And it's all built, it's all designed already. It's just a case of extending it and stabilizing the script loading sequence. It's also great for finding out, what needs to be shared, what's loading behind, what's a large bundle. Um, you could push up all the scripts that you have and look at the size of them, shaken and unshaken, and you could have Medusa decide what your shared response looks like. There's no reason that a query like that couldn't be written, considering you know everything. I know what is shared, but I also know what dependencies the thing has. And I even know its development dependencies. So you could start to, build recommendations on here and say, or just automatically do it and begin sharing things. If it fails, unshare it. And, you could have this engine be experimental like that. I think the API is flexible enough. And one other cool feature I'll show off is we've built in a couple cool things here. So we also have single sign-on, which is very handy. So what we're doing is we reach out to Graph, we pull back some version data, as well as some override data to know if I'm overriding the application or if I'm loading just the top level version. The thing is, we know who the current host is because we passed that in. We also know the remote that we're after, so which remote we're trying to go and get. But I believe we're returning more data than required. And I believe that the script loader I've built is attempting to load more than just the one application, but it's reading the database, getting the payload, and loading multiple remotes, or attempting to, instead of loading just the one remote that it needs. So something in this code needs to be adjusted. All right, so our server is back up and running. Let's jump back over here and let's hope we can get single sign-on. There we go. All right, so now in order to use the app, I need to sign in. Let's see if I have a session available here. Nope. All right. Okay, and now I'm signed in. And there's my logout button. Haha, I found it. Okay, so there's some hidden things in here, but one of the cool things that we also have now is webhooks. Or wait, settings. There we go. So when I go into settings, I can generate a token, and that's how I can pretty much specify a secret. If this were to go over the public internet, and you wanted your build graphs to go back through here, you could generate a token. You can also create webhooks when the application updates, when something's deleted, when a version changes, or when a version's removed, and what type of URL you want it to hit. And basically, when the dashboard gets something, it will relay that to CI or to anything else. I would see this being used mostly to manage cache, like to talk to the edge network, and maybe if like we're an Akamai Ion user, so I would imagine talking to the Akamai edge, which would then read or write to the Akamai Ion layer directly, and we could programmatically control the cache based on application version updates. And yeah, this is pretty much a breakdown of it. I can click into each component, I can see what I would need to load, how that module would be loaded, and how I could utilize that module. There's also a little wizard here. It's a little bit dated, so I need to get around to updating it, but it also has the ability to kind of help you configure it like a little wizard. And Lodash will change there, and it's just set as a singleton. Not necessarily the best scenario you always want, but useful here, labeling it to singletons. Things that you might want to expose out or exclude from being exposed. Apollo for one, that's a good one. And, components that you're wanting to point to. You can kind of list them out like this, and it'll basically, create this structure for you. And then you give the name of the application. And this is more or less how you can configure module federation. You can choose, what imported modules you'd want. This is basically what it would give you. We do have updated syntaxes we can use. This is still technically the most performant, but there are updated syntaxes where we can, load them inline. So, this is an old way of doing it, where everything's on the window. But you could have this be the at syntax and it load through the at syntax, which is kind of the default that Webpack uses nowadays. And yeah, this is, pretty much what everything looks like and what we have built out so far. And we're hoping that people take interest in this tool and give us good feedback. So yeah, that's it. It seems simple, but it's a lot more complex than you'd think to stitch these graphs together and make sure they kick off in the right order. Especially linking we don't know which order a remote or at what time a remote's loaded in, so how that remote attaches and in what queued order does that remote attach to this system has some, play, and also when it gets resolved. Technically, when the script is loaded, it doesn't necessarily mean the script is resolved or, pushed through the Webpack pipeline yet. So there's some, give and take in the mechanism itself that we still need to work out, but in its current use under a library like this, it is pretty stable. So yeah, that is Medusa at last.